So let's consider a spherical mirror example problem. So suppose we have a spherical mirror that has a focal length, because you normally get the focal length instead of the radius of curvature. So let's say the focal length is going to be 14.2 centimeters. And let's say we put an object at a distance of 18.8 centimeters from the mirror, and I want to know where is the image. Okay, so here we have focal length 14.2 centimeters. The object is 18.8 centimeters. And let me give you one other bit of information. Let's say that the object is 1.25 centimeters tall. And so I want to know the characteristics of the image. So for characteristics of the image, I want to know, is it real or virtual? I want to know, is it upright or inverted? Or we would sometimes say erect or inverted. Okay. I want to know the size of it. So that would be HI. And then I would know the position. So the position would be DI. Okay. So first step is you draw it. And the best way of drawing this would be to actually use a compass and a ruler and draw it to scale. So you would draw the mirror, okay, and the center of curvature of the mirror is there. So that makes the focal length right there. Okay, the focal length was 14.2 centimeters. And so the object would be located right about there. Okay, now to draw a ray diagram, you should always think about drawing the ray diagram. To draw the ray diagram, you draw a line straight towards the mirror, and it goes back straight through the focal length. Then you draw a line that goes straight through the focal, and then it hits the mirror and goes straight out this way. And then a line from the center curvature goes straight out. So that means the image would be right there. Okay, so there's my object, so there's my image. Now, if you draw this accurately, you could actually use a ruler and measure it and use whatever scale factor you drew to make the measurements. Okay, the three primary rays. There's always three primary rays, and you can expect maybe this on a test. It is to draw a ray diagram and then submit it. To draw the three primary rays, the first ray always goes from the object to the mirror and bounces off, goes to the focal point, and keeps going straight. The second one goes through the focal point and then hits the mirror and goes out straight. The third one goes to the center of curvature. Now, if the object had actually been further out, it would have gone to the center of curvature and then kept going to the mirror and then back. But it's a straight line through the center of curvature. Okay, where they all three come together is going to be the position, the image. Now, right away, you can tell a couple of things. The image is going to be upside down, it's going to be inverted, and it's going to be magnified. It's larger than the object. Okay, so now we know what's going to happen. So now what we can do is start using equations. So 1 over f, okay, so 1 over f equals 1 over di plus 1 over do. So 1 over f equal 1 over f minus 1 over do equals 1 over di. So di equals 1 over f minus 1 over do to the minus 1. So in this case, that'd be 1 over 14.2 centimeters minus 1 over 18.8 centimeters to the minus 1. So di comes out to be equal to, let's see, 14.1 comes out to be 56.4 centimeters. Okay, so this is 56.4 centimeters. Now, I asked for where. That's going to be the where. I also asked for the... Well, we know that HI over HO negative equals DI over DO. Okay, so that means that HI equals minus DI HO over DO. So that's going to be minus 56.4 centimeters times HO, we said there was 1.25 centimeters tall, and then divide by DO. DO was 18.8 centimeters. So HI is negative. Now, again, negative means it's upside down. So that comes out to be negative 3.75 centimeters. What's the magnification? Magnification is HI over HO. So in that case, it'd be minus 3.75 centimeters divided by the original 1.25 centimeters. So that comes out to be 3, or minus 3 times. Again, the negative means that it is upside down, does not mean that it is smaller.